Out of this world, what's up in space? A weekly look at the biggest news coming down to Earth from space. Scott Sutherland, meteorologist, science writer. Thursday, December 7, 2017, 15:51. This one shouldn't exist, but it does. Astronomers have found a quasar, an active supermassive black hole that is so distant, and thus so far back in time, that it challenges their models of how these gargantuan objects form. It's what's up in space. Supermassive black holes are thought to exist at the center of nearly every in the universe. Most are dormant, and thus are only seen by how their immense gravity affects the objects around them. In contrast, some, known as active supermassive black holes, or quasars short for quasi-stellar objects, are very bright, emitting intense light and radiation as they consume vast quantities of matter. These monsters, active or not, have never been seen forming, but the most solid ideas for the process behind their formation require it to take a very, very long time. A newly discovered quasar, known as J13420928, is now challenging that idea, though. This massive object, 800 million times more massive than the Sun, is now the most distant quasar ever found, and as a result, it is the earliest one ever observed. Who knows when it actually formed, but astronomers found that it existed when the universe was only 690 million years old, just 5% of the universe's current age of 13.77 billion years. This is the only object we have observed from this era, study co-author Robert Simcoe, from MIT's Kavli Institute for Astrophysics and Space Research, said in a statement. It has an extremely high mass, and yet the universe is so young that this thing shouldn't exist. The universe was just not old enough to make a black hole that big. It's very puzzling. The new supermassive black hole J13420928 yellow star, which resides in a mostly neutral universe at the edge of cosmic dawn, is more distant than any other found to date. Yellow dots. Credit Ginny Yang, University of Arizona Redahan, Fermilab M. Newhouse NOAOAURANSF. Being around when the universe was young puts this supermassive black hole at the cusp of when the universe emerged from its dark age, from the time before the first stars formed, to when light began to shine throughout the cosmos. So, this object was seen just at the edge of what we can see, looking that far back in time and space. Gathering all this mass in fewer than 690 million years is an enormous challenge for theories of supermassive black hole growth. Eduardo Banardos, the Carnegie Institution for Science astronomer who led the discovery, said in a press release on Wednesday. The three main ideas of how supermassive black holes form are: one, from the collapse of immense clouds of gas, which also form the around the black hole; two, from stellar black holes, ones that form due to the collapse of massive stars that gather even more matter to them over millions of years; or three, due to the merger of multiple black holes. With J13420928 being so large at such a young age, this offers a puzzle to astronomers. By comparison, Sagittarius A, the supermassive black hole at the center of our Milky Way, which is thought to have formed about 13.7 billion years ago, is only 4 million times the mass of the Sun. The team thinks that, perhaps, the conditions in the very early universe allowed for massive black holes to form, that started off at 100,000 times more massive than the Sun, and then grew from there. The team's findings are now published in the journal Nature. This is a very exciting discovery, found by scouring the new generation of wide-area, sensitive surveys astronomers are conducting using NASA's Wide-Field Infrared Survey Explorer in orbit and ground-based telescopes in Chile and Hawaii. Daniel Stern, a member of the team from NASA's Jet Propulsion Laboratory, said in a statement. With several next-generation, even more sensitive facilities currently being built, we can expect many exciting discoveries in the very early universe in the coming years. Sources: Carnegie Institution for Science, MIT. Watch below. C2 neutron stars merge to form a black hole.